Welcome to MRU E-Learning powered by Malla Reddy University. Myself, Tejasvi from Department of Computer Science and Engineering, School of Engineering, Malla Reddy University. Today, I am going to deliver lecture on substitution ciphers in cryptography. So before going to discuss about substitution ciphers in cryptography, let us have a look about the basics on cryptography. So now we will see what is the definition of cryptography, then we will see basic elements of cryptography. So cryptography means it is the science of protecting information using some mathematical techniques to ensure confidentiality, integrity as well as authentication. Or we can say cryptography is, cryptography is study of different cryptographic algorithms. By using that algorithms, we can convert unreadable or we can convert readable data to unreadable format. Okay. So now see this figure. So this figure illustrates different elements of cryptography. So the different elements of cryptography are plaintext, ciphertext, as well as decryption and encryption process. So coming to the explanation of this figure, so now a plaintext can be given as input to any encryption algorithm. Okay, so then the encryption algorithm produces ciphertext using the key, and at the receiver side, the ciphertext can be again decrypted and the receiver receives the plaintext again with the help of decryption algorithm. So now we will see the basic elements of cryptography. So first element is plaintext. So plaintext means original message that can be understandable by any human. So ciphertext means it is a coded language that cannot be understandable by unauthorized users. So only authorized users can be able to see the ciphertext. So next coming to cipher. So cipher means it is an algorithm or technique to transform plaintext to ciphertext, and the key we can use, it is the information that is used by the algorithm, and the key can be known to only sender as well as receiver. So coming to encryption as well as decryption. So encryption means it is the process of converting plain text to ciphertext by using some encryption algorithm along with key. So coming to decryption. So decryption is the process of converting ciphertext to plain text using the decryption algorithm along with the key. So coming to next one, which is cryptography. So which is the study of different cryptographic principles as well as methods, and cryptanalysis means it is the study of principles and methods while using the deciphering of the ciphertext without knowing the key. So coming to cryptology. So cryptology means both, it is the combination of cryptography as well as cryptanalysis. So now we will see different substitution ciphers in cryptography. So now we'll see the definition of substitution cipher. So substitution cipher is the cryptographic technique where the letters in plain text can be replaced by the letters with any other letters or numbers or alphabets. So we have different substitution ciphers are available. Those are Caesar cipher, Monoalphabetic cipher, Playfair cipher, Hill cipher as well as Vernam cipher. So let us understand one by one ciphers with the help of examples. So now coming to Caesar cipher. So we can call Caesar cipher or it is a shift cipher. So in the Caesar cipher technique, the letters of plain text can be replaced by other letters used by using a key value. Okay. So we have some formulas available for the process of encryption and decryption supported by Caesar cipher. So the formula for Caesar cipher encryption is C equal to P plus K mod 26. So where P is the plain text and K is the key value. So we can apply mod 26 operation, and at the receiver side, receiver want to get the plain text again. The Caesar cipher uses formula which is P equal to C minus K mod 26. So now we will understand Caesar cipher with the help of example. So now we are taking the plain text as hello, HELLO, hello plain text. So here the key value is 3. So that means we need to shift 3 values after the alphabet. Suppose for example, if A is present in the plain text, so after A, we need to consider 3 letters. That means D is the ciphertext for A. Suppose if B letter is present in plain text, that B can be replaced by E. So like that, we need to shift 3 letters to the right positions of an alphabet. So suppose for example for hello, for H the ciphertext is K, and for E the ciphertext is H, and for L it is O, and for O it is R. So like this, with the help of shift operation, we can convert plain text to ciphertext, and the same decryption is also possible using Caesar cipher technique with the help of left shift operation. So now we will see second substitution cipher. So the second substitution cipher is Monoalphabetic cipher. So it is a cryptographic technique where the letters of plain text are replaced with any one fixed letter. So we can choose any letter. So we have 26 alphabets are there. So out of 26 alphabets, we can choose any letter from A to Z. So we can consider it as a plain text character and ciphertext character. So here the relationship between plain text character and ciphertext character is 1-to-1 relationship. So now we will see one example for monoalphabetic cipher. So what is the example we are taking here is, so the plain text is GFG. So for G, randomly I have chosen a letter S, and for F I have chosen letter R, and for G already G is mapped to S. That means the ciphertext here is, the full ciphertext is yes or yes. So in monoalphabetic cipher, we can replace a letter with any fixed letter. So out of 26 alphabets, we can take any letter. So now coming to third technique. So third one is Playfair technique, so which is also called Playfair square. So mainly this Playfair technique is used manually for encryption as well as decryption. So it is quite fast when compared to other techniques, and it does not require any special equipment. So Playfair scheme follows 2 steps for the encryption process. First step is we can create the population matrix, and the size of population matrix is 5 by 5. And second step is encryption process. So in the first step, so we will see some rules for creating population matrix. So as already I told you that population matrix size is 5 by 5 matrix, and it is used to store keyword for the encryption as well as for decryption. So how to enter the keyword in the population matrix? There are some rules are there. We will see that rules. The first rule is we need to enter the keyword left to right as well as top to bottom. And if any duplicate letters are there in the keyword, we need to delete the duplicate letters. And we need to consider single cell for both the alphabets I and J, so that we can accommodate all the 26 letters in 5 by 5 matrix by considering I and J as the single cell. So consider one example for the keyword. So here I am considering Playfair example as keyword, and I am accommodating this Playfair example word in the 5 by 5 matrix. So here the first letter is P, next second letter is L, third letter A, fourth letter is Y, and fifth letter is F. So here the sixth letter is A. So here sixth letter is repeating, so no need to write. We need to drop the duplicate letters. Okay. So then we need to follow the same process, so that we need to accommodate all the 26 alphabets in the 5 by 5 matrix. Okay. So if you see here, so whatever the underlined letters, so those underlined letters are duplicate letters. No need to write again the duplicate letters in the matrix. So in this way, we can build 5 by 5 matrix with the help of a keyword. So that is the first step of Playfair. Coming to second step, which is the encryption process. So in the encryption process, first of all, whatever the original message is given to you, so the original message we need to divide into pairs. That means 2 letters. Suppose in your original message, if the number of characters are even, we need to add the dummy letter X at the end of the message, so that the message will get even number of letters. So now we will see what are the rules in the Playfair for the encryption process. So the first rule is, suppose if 2 letters are same in the plain text, then we need to add dummy letter between the 2 letters, so that we'll get extra letters. So next step is we need to locate 2 letters in the grid or in the matrix, and we need to find the positions of the letters. Okay. So next, the third one is, if the two letters are present in the same row, we need to replace the letter by taking the right side of the letter. And if the two letters are present in the same column, we need to replace that letter with the letter that is present in the same column. So if the two letters are not present in same row, suppose if the two letters are present in first row as well as fifth row, okay, so at that time we need to replace the letter in the same row, but that letter should be exactly present in the column of the other letter. These are the rules we need to follow for the Playfair encryption process. So the decryption process of Playfair is the reverse process we need to do. So let us take one example in order to understand the Playfair encryption process here. So the plain text is, my name is Atul, and already the keyword I have taken is Playfair example. So this is the keyword and this is the matrix for the Playfair example, and this is 5 by 5 matrix. So now we will see the example. The plain text we have taken is, my name is Atul. So that my name is Atul, we are going to divide into pairs. So the first pair here is MY and second pair is NA, third pair is ME. So like that we are going to divide the plain text into pairs, and for each and every pair we need to apply the Playfair encryption process by following the rules. So coming to the first pair, so the first pair is MY, and we need to locate where that M and Y letters are in the matrix. So here M is present here and Y is present here. So if both letters are present in different row and different column, we need to apply step 5. So the step 5 is we need to consider the next letter X, and that should be exactly present in the column of Y. So we can replace MY with X and F. So the first ciphertext for MY is XF. So next we'll take second pair. So the second pair of letters are NA. So for NA, again we need to locate where the letters are available. So N is available here, A is available here. So these two letters are present in different row and different column. So then we need to apply step 5. So exactly after N we have O is available, and after A, L is available. So the ciphertext for NA is OL. Now coming to the next pair is ME. So ME is located in the same row. That means we need to take the next letter after M. So after M there is no letter. We need to go back and we need to select I. So for M, I is the ciphertext, and for X the next letter is M. So M is the ciphertext. So for the third pair, we are going to apply step 3 to get the ciphertext IX. Now we will see the next pair, which is MK. So MK is also like that. So M is located here and K is located here. So we need to take the exact opposite letters. So for M, S is the ciphertext. For M, I is the ciphertext, and for K, S is the ciphertext. So the last pair. So like this, the process we need to continue. Suppose for the next pair, which is AT. So A is located here and T is here. So we need to consider PV as the ciphertext. So for the last one, which is UL. So UL is the last pair. So UL is located in the same column. So we need to consider the next letter. So the next letter of U is not available. So we need to go back and we need to take L as the ciphertext. And for L, the next letter is R. So R is the ciphertext. So LR is the ciphertext for UL. So now, after performing the encryption process by following the rules, my name is Atul. So we get the total ciphertext as XF, OL, IX, MK, PV, LR. So to decrypt the message using Playfair cipher, we need to follow the reverse process. So next cipher is Hill cipher. So what is Hill cipher? So Hill cipher means, so up to now we perform encryption only on single letter or a pair of letters. So Hill cipher works on multiple letters at the same time. So in order to understand about Hill cipher, we have a basic idea about matrix operations like matrix transpose, finding out the transpose of a matrix or matrix multiplication, and we need to compute the inverse of a matrix in Hill cipher. So now we will see the process of encryption in Hill cipher. So any plain text is given to you. So before doing the Hill cipher encryption process, we need to designate the alphabets with the numbers. Suppose here A to Z. So for A we are giving 0, for B it is 1. Like that you need to designate numbers for the alphabets A to Z. Z is 25. Okay, so now here in this example, the plain text given to you is CAT. So we need to write the numbers for C. So for C it is 2, for A it is O, and for T it is 19. So like that we need to construct one matrix for the plain text. That is the first step in Hill cipher. So next, after constructing the plain text matrix, we need to choose the key matrix. So the size of key matrix is 3 by 3 matrix here. So why we need to take 3 by 3 here? So because we are having 3 letters in the plain text. Okay. So based on the letters present in plain text, we need to consider key matrix. The size of key matrix is 3 by 3 here. Suppose if plain text has 2 letters, then we need to construct key matrix as the size of 2 by 2. So this is the random values I have chosen in order to construct key matrix. So after that, we need to multiply the key matrix with the plain text matrix so that we'll get some output. So after getting the output, we need to apply mod 26. So after applying mod 26, we'll get the result as 5, 8, 13. So the resultant matrix, we can call it as ciphertext matrix. Here, after getting ciphertext matrix, you are going to replace the letters according to the numbers. So for 5, it is F, and for 8, it is I, and for 13 it is N. So for the plain text CAT, we got the ciphertext as FIN if you apply Hill cipher encryption process. So now we will see the decryption process of Hill cipher. So in the decryption process, we are going to compute the inverse of the original key matrix. The original key matrix we have taken in the encryption process. So for that original key matrix, we need to compute the inverse of the key matrix. And this is the inverse of key matrix. Then you need to multiply the ciphertext matrix to the inverse of key matrix. After multiplying, we'll get one matrix. This is the resultant matrix. And for the resultant matrix, you need to apply modulo 26. Okay. So after applying mod 26, we are going to get the one matrix, that is the plain text matrix. So again, you need to replace the numbers with letters. So for 2, it is C, and for 0, it is A, and for 19, it is T. So in the decryption process, we are going to get the plain text. So now we will see the last substitution cipher, which is Vernam cipher. So in the Vernam cipher, we are going to use one-time pad in the encryption process. So whatever the plain text we are taking, the size of the plain text should be equal to the size of one-time pad. So these are the steps of Vernam cipher. So you need to write or you need to designate the alphabets from 0 to 25, same as in the Hill cipher. For A, we can take as 0, and for Z, it is 25. So similarly, we need to designate the one-time pad letters also with the numbers. Okay. So then the third step is, so just add the plain text characters with the one-time pad characters. So after adding, we are going to get sum, right? So that sum. We need to check the sum. Suppose if the sum is greater than 26, we need to subtract the sum from 26 so that we will get another number. So now we will see the Vernam cipher with the help of example. So the plain text taken here is how are you? And the one-time pad is this one. So we need to designate like this. For H it is 7 and for O it is 14. So like that we need to give the numbers for the plain text, and also for one-time pad we need to give the numbers here. So the one-time pad is NCBT. So for N it is 13 and for C it is 2. So just add the numbers. Okay. So 7 plus 13 which is 20. So like that we need to add the plain text characters with the one-time pad characters so that you will get some initial total, and after getting the initial total we need to check the total. Suppose if total is greater than 26, we need to subtract the 26 here. So 42 minus 26 which is 16, 31 minus 26 which is 5, and 43 minus 26 which is 17. Okay. So after getting the numbers, so we need to designate these numbers with letters. So for 20 it is U and for 16 it is Q. So like that we are going to get the ciphertext. So in the Vernam cipher we are going to add the plain text characters with the ciphertext characters to get the total. After that we'll get the ciphertext. So generally it is implemented in AT&T labs. So Vernam cipher uses only one-time pad. That means one-time pad we can use only for short messages. So one time only we have to use. For other messages we cannot be able to use. So therefore Vernam cipher is the simple substitution cipher we can use in order to send or in order to encrypt only short messages. So I hope everyone got an idea about the substitution ciphers in cryptography, and thank you very much.